So our 6 trig functions that we're dealing with all have different signs depending upon which quadrant they fall into as it rotates around. So here we've got the Cartesian coordinate plane divided up into its 4 quadrants, quadrant 1, quadrant 2, this is quadrant 3, and quadrant 4. And as our point here rotates around in a circle, we can see that x and y are going to be changing. When I am here in quadrant 1, all of my 6 trig functions will have a positive value. Okay, so all values are going to be positive in quadrant 1. And that falls because both x and y are positive. And remember that all of my trig functions are basically just the ratio of y over x in some form or fashion, or y over r, or x over r. And so the sign on both x and y is going to determine the sign of my trig function. So in quadrant 1, all 6 functions are positive. As I move into quadrant 2, sine and therefore cosecant, because they're reciprocals of each other, are positive. Tangent, cotangent are positive. They're the only ones that are positive down here in quadrant 3. And then cosine and secant are the only ones that are positive here in quadrant 4. So again, as I'm moving around the circle, depending upon which quadrant I'm in, will determine which of the 6 signs are going to be positive. And if these are, let's say I'm in quadrant 2, if sine and cosecant are the only ones that are positive, then the remaining 4 trig functions would be negative. To help you remember this diagram here, or which trig functions are positive, there's a little kind of pneumatic formula that says all students take calculus. And that comes from the fact that all students take calculus. As I rotate around the circle, the A comes from all, S comes from the sine in quadrant 2, take, the T comes from tangent in quadrant 3, C comes from cosine in quadrant 4. So all students take calculus. So taking that idea, let's practice an example down here. Here, for example 2, I want to determine the sign of my 6 trig functions. And the first part would be if I have an angle measuring 54 degrees. The one thing I hope you learn in trig that's going to help out the most is let's start by drawing a picture. So if I have just a rough sketch here, and I know that my angle is 54 degrees, 54 degrees falls somewhere here in quadrant 1. Since I'm in quadrant 1, I know that all 6 trig values are going to be positive. Okay, so drawing a picture kind of helped me just visualize where is my angle falling so that I can then apply what I know about the functions. Let's look at this one over here. This one talks about 260 degrees. So 260 degrees is going to rotate all the way past 180 and come over here into quadrant 3. If I'm in quadrant 3, then I know that tangent and cotangent are both going to be positive, and the remaining, so the rest, would have a negative value. Okay, so I'm not going to write all of them down, but I know that only tangent and cotangent will be positive, and the remaining 4 will be negative. Okay, the last one we want to look at for this part would be negative 60. So again, I'm going to draw my quadrants here, and I'm going to place negative 60. If I have a negative angle measurement, that means I'm rotating clockwise instead of the standard counterclockwise. So if I go clockwise, that means I'm going to drop down here immediately into quadrant 4. And so if I'm in quadrant 4, okay, cotangent and it's not cotangent, cosine, excuse me, cosine and secant are positive, and then the rest would be negative. So all students take calculus is going to help me determine what the sign is for each of my trig functions. Let's look at that maybe in a different way. Here I have another example. This example says, okay, suppose I have theta, and theta falls between 45 and 90 degrees. And I want to find out what the sine of each of my functions is if I am looking at 2 theta. Well, let's just first write this out. I know that if I have the sine, I know that if I have theta, and theta is falling between 45 and 90 degrees, that's going to be somewhere here, right? Between 45 and 90 degrees. Well, if I have 2 theta, in other words, if I am talking about twice my angle measurement of theta, then I would have to multiply both of these boundaries by 2. So now I'm looking at 2 theta is between 45 times 2 is 90, and 90 times 2 would be 180. So in other words, I just shifted my angle over here. This would be 2 theta. Now if I'm talking about 2 theta, then the sign on my function values tell me that I'm looking at, since I'm in the second quadrant, sine and cosecant would be positive, and then the rest would be negative. Okay, so that's kind of a different way to look at our signs. The final example I want to look at for this section says I need to identify which of the quadrants my angle is falling in if I'm given these 2 restrictions here. So I have 2 examples here. This is the first example over here on the left. If I know that the tangent of theta is greater than 0, well, if a value is greater than 0, it is therefore positive. And I need to think to myself, where is tangent positive? Tangent is positive in the first quadrant because all values, all trig functions are positive in the first quadrant. And tangent is positive in the third quadrant. Okay? So that's one of my restrictions. The second criteria says, well, cosecant of theta is going to be less than 0, so in other words, it's going to be negative. Where is cosecant negative? Well, cosecant, which is the reciprocal of sine, okay, cosecant would be negative in quadrants 3 and in quadrant 4. So if I have these 2 criteria here, notice that quadrant 3 shows up for both of them, therefore it overlaps, in other words, and my angle theta, given this criteria, would be falling in quadrant 3 if tangent were positive and cosecant were negative. That's what we're being asked. Okay, so let's think about that one more time. Let's do that again. The sine of theta is greater than 0. In other words, where is sine positive? Well, sine is positive in quadrants 1 and 2. Cosecant of theta greater than 0, so in other words, where is cosecant positive? Cosecant is positive in 1 and again in 2. So if the sine of my angle is positive and the cosecant of my angle is positive, then my angle is actually in quadrants 1 or 2.